Okay, so welcome back, everyone. Our new lesson for this time is all about hypothesis testing. But before that, I'd like to recall what we have learned last week. Previously, we discussed confidence interval for determining uh, for the mean, confidence interval for the proportion, and confidence interval for the standard deviation or the variance. So if I have to recall or recap our previous topic, I remember we introduced the idea of sampling distribution. The reason why it's because it's very important because it's the most important or the third important property of the CLP or the central limit theorem. And since we always do sampling, we uh, cannot access the whole population. That is where CLT can be applied. Even though for the sake of illustration, we only introduce the idea of sampling distribution of the mean. Uh, the idea can be extended to the sampling distribution of proportion, sampling distribution of variance, sampling distribution of standard deviation, or any other statistics about the sampling. So this time, we're gonna discuss the hypothesis testing. So for the topic outlines, we're gonna learn the traditional method of hypothesis testing. What are the steps? Um, Hypothesis testing for the mean using the z-test. Hypothesis testing for a mean using t-test. And of course, it's applicable if the standard deviation is unknown. The z-test for the standard deviation that is known. Hypothesis testing for a proportion using, again, z-test. And the last is the hypothesis testing for a variance or standard deviation, and that is using chi-squared test. So what we have here is a question such as how much better is better. So for example, suppose a school superintendent or a principal or any other public teacher claimed that a particular section, let's say A, B, or C, their grades or their scores in one subject is higher or lower than the other sections. So the question is, can that principal or superintendent conclude that the students in his school district scored higher on average compared to other sections? So of course the answer is not straightforward because using only low numbers, using only aggregate numbers such as average, doesn't tell you the whole story of the distribution. So you should always look at the distribution, the base of the distribution, the shape of the distribution, and of course the centers of the distribution. So for the sake of illustration, what you can see here is the distribution of individual income by gender. So we have a distribution for women and we have a distribution for men. And as you can observe, because not only you can derive the average for the men and women, but you have the whole picture. You have the distribution. So first thing we can observe is the shape of the distribution, both for men and women, is skewed to the right. So both men and women, the distributions are skewed to the right. That's the first observation. The second observation is the percentage, meaning the frequency. The frequency for women, especially at the lower end, is greater or times two or more than times two than the percentage of the men for the lower distribution part. That's the second observation. And I think the third observation here is that the average income, individual income of women is less than the average income of men. So as you can see, if you have the whole picture, you can observe more and you can describe more accurately compared to knowing only the centers. So it's not enough, right? You must have the whole pictures. So that's for example. Another example, this one is the distribution for the IQ, comparing again men and women. So this information come from different sources. I don't know the different sources, but I just happen to have them put here. So I think they all speak more or less the same uh, uh, things. So let's try to say something about this graph because we don't only know the average or the aggregate of the two distributions, but also their shapes and their spread. So as you can see from the upper left, the distribution or the average IQ for both sexes are different. The other is, of course, greater than the other. And if you can look at the x-axis, the units for the general intelligence G is standardized because you have their zero, negative, and positive numbers in terms of standard deviation. On the lower end, we see the comparative sex IQ distribution. Can observe that the IQ probability density for women is higher than the probability density of men. And the second observation is that the probability distribution of men is wider. Okay, so that's the second observation there. Actually, the third graph on the right, they are just the same to the graph here on left. It's just a matter of data presentation. So here we can observe, actually I um, uh, encountered uh, some threads in Twitter many years before, and I can't remember the conclusion of the count. Um, but if you can say something about the graph in the figure 9.4, the y-axis is the fractional of the population. So it's 0.2, 0.3, 0.4, 0.5, and up to 0.8. So it's just a ratio of male to female. And the IQ score is not standardized. So we have 60 up to 140. And what this graph basically shows is the ratio of male to female for that specific IQ score. And as you can see or observe, uh, the ratio at higher end, we can see that the male is at the top and the female is at the bottom, and but the IQ score at the lower end is still the same. It's still the same. So, in other words, if you can say it in our language, it just means that um, men are extreme. Okay, mas damo alam ng laki relative to babae on that magnitude, but at the same time, mas damo man mango ang laki with respect to that IQ score. That's why um, you can observe it easily man sa society like ang basurero, ang construction workers, or even ang mga preso. So, sa pinaka-lowest yung part, may damo ang malaki. Sa pinaka-taas yung part, damo man ang malaki. That's because men are extremes, no? And it's general nga behavior, yeah. That's actually one of the conclusions. No, women tend to conform. That's why meron sila sang here you can see that the women is concentrating in the middle. Okay, so this is just for the sake of illustration to the question, how can we say that the average is enough? So we need to have the whole pictures. Many examples are also good, but it just happens that this is what I found in Twitter.